Hello, and thank you for joining us today. I'm Seb Dunham in the Office of Graduate Studies for the Columbia College of Arts and Sciences here at the George Washington University. We're excited to have you here for our MS program in Environmental and Green Chemistry. So I will start with or I'll give you a quick overview of our presentation. So today, Professor Kostal is going to give you an overview of their program, and then we'll open it up to Q&A. So there's a Q&A box function at the bottom of your screen. If you want to submit questions through there, you can submit questions during the presentation. Just be aware we might not answer them till the end of the presentation. But then once the presentation's over, it's going to be pure Q&A. So just whatever questions you have, we're here to answer. But so without further ado, I'm going to turn over to Professor Kostal to get started.
All right, thank you, Seb. So, welcome everyone. Well, happy, I would say afternoon, evening, morning, wherever you are in the world. So I'm the director of the master's program in environmental green chemistry at GW. It's a program that's been around for almost 10 years now, quite successful. And I want to just give you a sort of an overview of what we are about, the flavor of some of the courses and projects that the students get to work on, and how that may link or support your future career. So, see if I can. So the basis of our program is again to address some of the great challenges of the 21st century. And outside of global warming, it's really the chemical pollution and the unintended consequences of the chemical industry that have spurred a lot of green chemistry, environmental chemistry efforts to figure out how can we make chemicals that are useful to us, but also have a minimal or no environmental and human health impact. And of course, you're all familiar, if you're here listening to this, that unfortunately in the past, we have not been that successful as a society to mitigate some of these impacts. So we have been releasing a lot of toxic chemicals into air, land, water. We have accumulated waste in the oceans, and very few of these chemicals that we release are actually properly studied. So one of the goals of this program is to figure out, well, what are these chemicals that we synthesize, we commercialize, and what are their hazards, what are their risks, and how can we potentially replace them with substitutes that would be better for us. Now, there are a lot of noble reasons why to join our program. There are some pragmatic ones too. The pragmatic one would be that sustainability, green chemistry jobs have been on the rise, and that's despite political changes. That's just been kind of a steady growth. So if you look at where DC is, or surrounding Maryland or Virginia, there have just been a lot of jobs in this area that would label themselves as sustainable or green. So a lot of our graduates are finding jobs with relative ease. I would say most of them actually find their dream job way before they graduate. So sometimes finishing up the second year feels more like a hurdle for the student than the idea that they would have to struggle to find a job. So tons of opportunities how to leverage your skill sets after you graduate. We're based in the chemistry department, which is part of the science and engineering hall at GW. It's a beautiful, new, huge space, very open, very collaborative space. You're part of the chemistry department, so you get to interact not just with the ENGCs or environmental green chemistry cohort, but also with other masters and PhD students in the department. We are perfectly situated in the DC area, as I mentioned. For the nature of the program, we work very closely with a lot of the government agencies around here, like the US EPA, the White House Council on Environmental Quality, the US Department of the Interior, NOAA, and so on. So we have a lot of connections with these organizations, and the fact that you would be in DC in walking distance from their offices is great for networking. Yes, and it's outside of, again, the sort of academic value of the program. Being in DC, DC also ranks in the top 20 of best places to live in the US. So a great city, very green, and easy to commute to, which is something that all of our students appreciate. So let's dive a little bit into the program itself. The mission is to provide you with this cross-disciplinary advanced training in areas of physical sciences and environmental challenges that we face today. So you're going to get a flavor of environmental chemistry, green chemistry, computational chemistry, and how all of those affect sustainable manufacturing and development of chemicals today. And the goal is to train you to be subject matter experts that can take that knowledge and work in industry, government, or NGOs. And again, a lot of those are literally around. So you will get to meet important people from these organizations way before you graduate. I list a few learning outcomes here, but again, a lot of this detail, if you just snap the QR code on our first slide, can be obtained from our website, from our LinkedIn page. Again, the main ones are you being able to understand, assess environmental impact of chemicals, to develop solutions to prevent or eliminate pollution and chemical hazard, and then to design new chemicals and chemical processes that minimize that environmental impact. And lastly, which will be especially relevant for any future career you have after you graduate, is to be able to communicate your science to not just your colleagues, but also to the general public. The program is very selective. We insist on having a very good faculty to student ratio. So we have 4 core faculty, and our student cohorts are always under 10 students a year. So we insist on having a very sort of close mentorship. So that's only possible if there's a small cohort of students. The program consists of 30 credit hours. It's usually taken over 2 years. Some of our students have sort of been enrolled full-time. Some of them have extended this a little bit and worked part-time. We have 6 core courses that are offered within the chemistry department. One is on energy, another is on environmental analytical chemistry, then there's one on air, water, and soil chemistry, and then there are 2 green chemistry courses, one on industrial green chemical processes, and one on chemical toxicology and the safer chemical design. And then there's the 6th course is sort of a group project, if you will, with an external partner to the program. It's called a capstone seminar. So altogether, these constitute 18 credits, and the remaining 12 credits you would usually take in form of electives. We kind of, those are generally open as far as, what schools or what specific classes you want to take. We will normally work with you to figure out, what are the type of classes that you may want to take to support your future career, to complement the core courses in the best possible way. Students have taken courses at, of course, the chemistry department, other graduate chemistry courses, courses at GW School of Public Health, School of International Affairs, Public Policy Administration, data science, computer science. So there are a lot of different flavors depending on whether you skew more policy, you skew more technical. And because GW is in a consortium with Georgetown and University of Maryland, you can also take classes in those. In fact, a lot of our students take electives at Georgetown. These are the 4 core faculty that we have in our program. And those are the faculty that you will see teaching the core courses that I just mentioned. We have a lot of educational partners. So we work with Sustainable GW. We have helped develop a curriculum for Beyond Benign, which I encourage you to check out. That's a very good nonprofit based in Boston that's been building coursework to bridge toxicology with chemistry for undergrad and graduate students. We're part of the Molecular Research Design Network with Yale and Baylor University. We're also on Sustainable Scientists, or NICE. And we are one of the premier programs recognized by the ACS Green Chemistry Institute, which is coincidentally also one of our academic partners, and it's literally walking distance from GW. Just to go a little bit over the core courses, I mentioned environmental chemistry of water, air, soil. So in this one, you will study behavior, movement, and impact of chemicals in air and water. You'll look into the chemistry and environmentally important cycles, and then study the various human factors like acid rain, sewage treatment, ozone destruction, and so on. You'll have a course on environmental analytical chemistry, which really focuses on the modern analytical techniques and how they apply to various environmental challenges. So you'll become familiar with analytical instrumentation, with remote measurements, trace atmospheric constituents, and uncertainty analysis, studying of pollutants in air, water, soil, and biota, looking into heavy metals, radionuclides, and so on. The emphasis here is on the priority pollutants according to U.S. regulatory agencies, which means mostly the list of chemicals that are defined by the U.S. EPA. The course on energy and environment looks into the fundamentals of energy conversion and thermomechanical, thermochemical, electrochemical, and photoelectric processes, looking into existing and future power systems, transportation systems, and again, focus here is largely on efficiency, environmental impact, and performance. The two green chemistry courses are split into focusing. One is focusing on industrial chemistry, that is onto chemical processes. So basically surveying how chemicals are made and what we could do to make them better, looking into catalysis, the use of renewable starting materials, the minimization of energy inputs, and use of greener solvents. And then there's a course on chemical toxicology and safer chemical design, which really looks at the hazard that's associated with the chemicals that you make through various chemical processes. Here you will learn about what the basic tools are that we have in toxicology to assess hazards of chemicals. You'll learn how to model some of these hazards when we don't have animal or assay data. You will learn how we can predict bioavailability, reactivity, bioaccumulation, environmental persistence, and other endpoints. Kind of a very exciting cross-disciplinary course between computational chemistry, some techniques, modeling techniques borrowed from medicinal chemistry, toxicology, and green chemistry. The last course that you will take in the last semester of your second year is the capstone seminar, which is a group-based project that's done in partnership with an external client. This can be a government agency. We have very close connections with the EPA, WHO, USGS. We also work with a lot of NGOs in the area, like the Environmental Defense Fund, Natural Resources Defense Council, Clean Production and Action, BizNGO, and others. We also work with industry, a lot in personal care, like Seventh Generation. You've probably encountered some of their products if you have been to, say, Whole Foods. Dow, DuPont, big chemical manufacturers, also Doc Services, various 3. These are hazard assessors, so companies that are interested in predicting or modeling or generating data for hazard. Eastman, Patagonia, Seal, SaferMate, Impora, so various companies that either manufacture the final products or are somewhere in the supply chains of the larger companies. We also work with industry groups and roundtables like the GC3 Council, which is now called Change Chemistry. I mentioned ACS, Institute for Green Chemistry. We have also worked with the American Chemistry Council, which is a lobby group for the industry. And we have academic partners. We work with Berkeley Center for Green Chemistry, Yale Center for Green Chemistry, Green Center Canada, and quite a few others. Just to give you an idea of what some of these projects are in the capstone. So this is a list of the key projects from the past 2 years. So last year we had a big cohort that worked on looking into PEX versus PVC as materials in water supply lines in the US. And this was directly in collaboration with the White House Council on Environmental Quality and the US EPA. So the final report actually went to these agencies and was used under the Biden administration, was used as one of the sort of informational repositories for their sustainability report. And then hopefully for some future decision making. We have had project on environmental justice and equitable distribution of green chemistry in indigenous communities. This was in collaboration with US EPA, the TRI division, and SEAL. There was a small group of students that in 2023 worked on helping develop new alternatives in safer waterproof, breathable textiles. This was in collaboration with a startup from ETH Zurich called Tempora, but we also brought in folks from SaferMade, which is a big investment fund that looks into investing in startup sustainable and green chemistry technologies. We brought in Patagonia, Eastman, and NRDC. So we kind of had the whole landscape of players or key stakeholders that will be interested in something like a waterproof, breathable. So your new replacement for your Gore-Tex in your jacket. And then the last one I'm mentioning here is a study of PFAS, these polyfluorinated substances and their degradation in the environment and environmental fate. And that was done in collaboration with U.S. Geological Survey, and it was a combined data analysis, but also experimental project. So not everything is just dry lab. Some of it is actually hands-on work in a field. I should mention internships, so just to kind of get you a sense of what the students usually do. So mostly you will get the core courses and your electives out of the way in the first year, and then between your first year and second year, students take on internships. There are plenty in the DC area, and we would help you make those connections, especially when it's with government agencies and NGOs that we work with through the capstone or other engagements. You can also participate in research with some of our faculty. I mentioned the 3 that have in the past had students from the EGC program. I've had some, and you can check out the research that we do. I'm a purely computational group, so we do a lot of modeling in toxicology and green chemistry. If you're interested in analytical chemistry or energy research, then the Miller Research Group might be a good fit. And then the Pincus Research Group is also something that you should probably check out. Financial aids, Sep will probably talk about this, but there are some fellowships that are available through GW. You can also apply to be a teaching assistant for the chemistry department, which many of our students do. You can apply for a campus job if that your visa situation allows for this. And many of our students have part-time jobs. In fact, in the past 2-3 years, I think every student in every cohort has held onto a part-time job that they would acquire sometimes in their first year. And then come second year, they will be taking classes, whatever remaining classes they still have to take while working. You may wonder where our students go. I kind of alluded to this already, but we place students very easily given the unique skill set that you built in this program. A lot of our students go work for the US EPA. The past, some students have gone to work for the American Chemistry Council, which again is the umbrella lobby group for the industry. So to hopefully promote some safer, more sustainable practices across industry. We have had students go to work for Syracuse Research Corporation, which is a big contractor to the government that helps, for example, develop hazard assessment tools. I'm listing a few others like ClimeCode, the Joe Group, Sustainable Building Partners, Battelle, that's a consulting group, Energetics, Clean Energy Consulting, and General Dynamics Information Technology. We have also had some students go into law schools to kind of combine their technical skill set in sustainability, green chemistry, environmental chemistry with law that would help spur changes, policy changes on that front. So, for example, one of those organizations that we work very, very closely with, NRDC in the DC area, which is the Natural Resources Defense Council, is very heavy on litigation, either with industry or the government, to promote safer, more sustainable environment. So that will be a great connection to make if you're interested, for example, in pursuing a law degree after you graduate from our program. So that's all for me. I didn't want to keep this too long, and I'm